The Foundations of Geometry by David Hilbert.
Chapter 5, Desargues' Theorem. Section 26, the Associative Law of Multiplication and the two distributive laws for the new algebra of segments. The Associative Law of Multiplication, A times the quantity BC equals the quantity AB times C, has also a place in our new algebra of segments. Let there be given upon the first of the two fixed straight lines through O the segments 1 equal to OA, B equal to OC, C equal to OA prime. And upon the second of these straight lines, the segments A equal OG, B equal OB. In order to construct the segments BC equals OB prime and BC equals OC prime, AB equals OD, and the quantity AB times C equals OD prime in accordance with section 24. Draw A prime B prime parallel to AB, B prime C prime parallel to BC, CD parallel to AG, and A prime D prime parallel to AD. We see at once that the given law amounts to the same thing as saying that CD must be parallel to C prime D prime. Denote the point of intersection of the straight lines A prime D prime and B prime C prime by F prime, and that of the straight lines AD and BC by F. Then the triangles ABF and A prime B prime F prime have their homologous sides parallel to each other, and according to Desargues' theorem, the 3 points O, F, F prime must lie in a straight line. Because of these conditions, we can apply the second part of Desargues' theorem to the two triangles CDF and C prime D prime F prime, and hence show that, in fact, CD is parallel to C prime D prime. Finally, upon the basis of Desargues' theorem, we shall show that the two distributive laws, A times the quantity B plus C equals to AB plus AC, and the quantity A plus B times C is equal to AC plus BC, hold for our new algebra of segments. In the proof of the first one of these laws, we shall make use of figure 46. In this figure, we have B equal OA prime, C equals OC prime, AB equals OB prime, AB equals OA double prime, AC equals OC double prime, etc. In the same figure, B double prime D sub 2 is parallel to C double prime D sub 1, which is parallel to the fixed straight line OA prime, and B prime D sub 1 is parallel to C prime D sub 2, which is parallel to the fixed straight line OA double prime. Moreover, we have A prime A double prime parallel to C prime C double prime, and A prime B double prime parallel to B prime A double prime, parallel to F prime D sub 2, parallel to F double prime D sub 1. Our proposition amounts to asserting that we must necessarily have also F prime F double prime parallel to A prime A double prime and to C prime C double prime. We construct the following auxiliary lines. F double prime J parallel to the fixed straight line OA prime. F prime J parallel to the fixed straight line OA double prime. Let us denote the points of intersection of the straight lines C double prime D sub 1 and C prime D sub 2, C double prime D sub 1, and F prime J, C prime D sub 2, and F double prime J by G, H sub 1, H sub 2, respectively. Finally, we obtain the other auxiliary lines indicated in the figure by joining the points already constructed. In the two triangles A prime B double prime C double prime and F prime D sub 2 G, the straight lines joining homologous vertices are parallel to each other. According to the second part of Desargues' theorem, it follows therefore that A prime C double prime is parallel to F prime G. In the two triangles A prime C double prime F double prime and F prime G H sub 2, the straight lines joining the homologous vertices are also parallel to each other. From the properties already demonstrated, it follows by virtue of the second part of Desargues' theorem that we must have A' F" parallel to F' H sub 2. Since in the two horizontally shaded triangles OA' F' and J H sub 2 F', the homologous sides are parallel, Desargues' theorem shows that the three straight lines joining the homologous vertices, namely OJ, A' H sub 2, and F" F', all intersect in one and the same point, say in P. In the same way, we have necessarily A" F' parallel to F" H sub 1, and since in the two obliquely shaded triangles OA" F' and J H sub 1 F", the homologous sides are parallel, then in consequence of Desargues' theorem, the three straight lines joining the homologous vertices, namely OJ, A' H sub 1, F', F", all intersect likewise in the same point, namely in point P. Moreover, in the triangles OA' A' and J H sub 2 H sub 1, the straight lines joining the homologous vertices all pass through this same point P, and consequently it follows that we have H sub 1 H sub 2 parallel to A' A', and therefore H sub 1 H sub 2 parallel to C' C'. Finally, let us consider the figure F" H sub 2 C' C" H sub 1 F' F', since in this figure we have F" H sub 2 parallel to C' F', parallel to C" H sub 1. GH sub 2 C' parallel to F" C', parallel to H sub 1 F'. C' C" parallel to H sub 1 H sub 2. We recognize here again figure 43, which we have already made use of in section 25 to prove the commutative law of addition. The conclusions, analogous to those which we reached there, show that we must have F' F" parallel to H sub 1 H sub 2, and consequently we must have also F' F" parallel to A' A', which result concludes our demonstration. To prove the second formula of the distributive law, we make use of an entirely different figure, figure 47. In this figure, we have 1 equals OD, A equals OA, A equals OB, B equals OG, C equals OD', AC equals OA', AC equals OB', BC equals OG', etc. And furthermore, we have GH parallel to G', H', parallel to the fixed line OA. GH parallel to A', H', parallel to the fixed line OB. We have also AB parallel to A', B', BD parallel to B', D', DG parallel to D', G', HJ parallel to H', J'. That which we are to prove amounts then to demonstrating that DJ must be parallel to D', J'. We denote the points in which BD and GD intersect the straight lines AH by C and F, respectively, and the points in which B', D', and G', D' intersect the straight lines A', H' by C' and F', respectively. Finally, draw the auxiliary lines Fj and F'J', indicating in the figure by dotted lines. In the triangle ABC and A'B'C', the homologous sides are parallel, and consequently, by Desargues' theorem, the 3 points OCC' lie on a straight line. Then, by considering in the same way the triangles CDF and CD'F', it follows that the points O, F, and F' lie upon the same straight line, and likewise from a consideration of the triangles FGH and F'G''H', we find the points O, H, and H' to be situated on a straight line. Now in the triangles FHJ and F'H''J', the straight lines joining the homologous vertices all pass through the same point O, and hence, as a consequence of the second part of Desargues' theorem, the straight lines Fj and F'J' must also be parallel to each other. Finally, a consideration of the triangles DFJ and D'F'J' shows that the straight lines DJ and D'J' are parallel to each other, and with this, our proof is completed.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.